Alright, in this video I'm going to go over my final project for Elicia White's Making Embedded Systems course. This is my final project. This is a particulate monitor and alarm device. It consists of a PM2.5 sensor, OLED screen, 2 buttons for calibration. I don't have a label maker, so I haven't labeled them yet. A alarm silencing button and an alarm passive buzzer here. So inside the box, we can take a look real quick, is the STM32F4 development board there, and then all of the other components wired up directly to it. For the PM sensor, it required a resistor and a capacitor. So I just kind of soldered those directly into the wiring there. And then also just to kind of promote airflow through the PM sensor. You see the PM sensor is supposed to flow through the sensor, through that hole. So to kind of promote natural convection and airflow, I cut some holes in the bottom of the box to kind of promote airflow going in there. So yeah, basically the idea is you hang this thing in your kitchen or nearby your kitchen or something, and it'll kind of alert you if you've forgotten to open windows or turn on your ventilation fan in your kitchen, and the house starts filling up with smoke. That happens sometimes when we're cooking hot wings or something at a high temperature, or something greasy and with some kind of an oil with a low smoke temperature and stuff. It can get pretty smoky, and pretty unhealthy levels of air pollution can pretty quickly build up inside. So this is kind of designed to be kind of an early warning thing you can hang on your wall and remind you and beep at you that it's starting to get smoky in here. So when I turn it on, you'll see it undergoes just a quick LCD and buzzer test just to make sure they're connected right. So I'll turn it on now. So after that quick startup test and after everything's initiated, it starts running pretty quick. I didn't bother converting the A to D counts from the PM sensor. This thing outputs voltage 0 to 3 volts, I believe. So I just kept them as A to D counts. I didn't really go through the trouble of converting them to volts or converting them to actual concentration, because the main idea is to just be able to, alarm at some A to D count value. So converting the units of measure wasn't really a big priority. You'll see it also shows the mode. So right now it's in measure mode, so it's just taking continual readings. The default baseline A to D count is 15, and the alarm level is 500. And you can change those with these 2 cow buttons. This will update the baseline. So if you push this button, it'll trigger an interrupt, and it'll start taking a pretty long average. So yeah, just push it there. Now it's in baseline mode. It'll just do this for maybe 20 seconds. It'll take a nice long average of its readings that it's currently having and store those as the baseline. Okay, then it goes back into measurement mode. And then right now I don't feel like making my house all smoky and stuff to get an upscale measurement. So I just have a humidifier here to simulate some particulate matter. So if we push the other cow button, it'll start taking an average that is supposed to represent a smoky room or something. So you can get this kind of situation here by holding the device like over the oven or something while you're cooking, maybe under the ventilation. And then you see after it's set, it went back into measurement mode, and it alarmed a couple times there because it had gone back into measurement mode, and I was still spraying it with the humidifier. So you'll see if you spray it with the humidifier again, you'll get the elevated readings above the threshold there, and it'll alarm. And if you want to silence the alarm, you can push this button, and that'll just take the buzzer out of its circuit. So it'll still flash, but you won't hear the alarm. So this is a latching button that just when you press it in, it has the buzzer in the circuit, in the PWM circuit that's triggering the buzzer, and if you push it out, it opens up that circuit. So yeah, that's about it. Thanks.